K-means clustering is the most popular approach for partitioning a dataset into k distinct non-overlapping clusters. To perform k-means clustering, we must first specify the desired number of clusters. In other words, we need to assign a value for k. That k represents the number of clusters, then the k-means algorithm will assign each observations to exactly one of the k clusters. This is a simple algorithm. You can see that this is algorithm in words, but I will demonstrate using an example. Okay, let's suppose this is our data in two-dimensional space, and first we need to specify the number of clusters. This is the initial point of k-means clustering algorithm. Let's suppose we want 2 clusters. Our k is equal to 2 now. Okay, after that we need to identify 2 random points which you consider as the center of those 2 clusters. We call them centroid as well. You just put 2 random points here. You can put these 2 anywhere of this two-dimensional space. So if your k was, let's say, 3, then you will put 3 random points, and these could be placed anywhere in the 2D plane. It doesn't matter. Next step is to identify the distance of each of these data points from the centroids. Okay, let's say you need to calculate distances. This distance, this, not only that, this. You need to calculate all the distances. And so why do we need to identify the distances? Because in k-means clustering, we have to minimize within cluster variation. So there are many possible ways to define this concept, but for the most common choice involves squared Euclidean distance. Thereafter, you need to allocate observations to the cluster which gives minimum distance. For example, now this data point is closer to red centroid and it belongs to red cluster, whereas this point is more near to this centroid and that data point belongs to green cluster. Now we got 2 clusters. You can see that clearly. These 4 are in one cluster and these points are in a green cluster. But we need to improve this further because this is not optimal. So then you have to calculate mean of each cluster. At the beginning we put 2 random points as a centroid, but now you can calculate real means for these 2 clusters. Using these 4 data points, you can calculate the mean for this red cluster, and using all these data points, you can calculate mean for green cluster. And this is the real mean for those 2 clusters. You can see that in this side. These are the red mean, this is the mean for the green cluster. So now we have new centroid for our 2 clusters. Then our next step is recalculate the distance of each of these data points from new centroids and reallocate the data points to the clusters while minimizing within cluster variation, as we did in earlier. In other words, if the point is more near the red, you put it into red cluster, otherwise you put it into the green cluster. Okay, you need to recalculate distances, which means you need to calculate this distance, this. Not only that, you need to calculate this distance, this, all of these distances you need to recalculate. And as you can see that these points got changed now. You can see that previously this is a red cluster, but now these 3 green points are now closer to the red cluster. Okay, now you can see that there are these 3 these 3 green points, now it belongs to red cluster. And this is our, now again we obtained 2 clusters, but we cannot say that this is the optimal one. We need to improve this further. You keep on repeating this process. You just recalculate your centroids, then recalculate the square distance of individual data points from these centroids, and readjust the clusters until the point that none of the data points change in the clusters. You need to calculate. You need to do the same procedure. And you can see that now after the procedure, you can see that this data point now belongs to red. You can see that now we obtain 2 clusters again. So after this, we are done now. We are done. Then so even if you try to recompute this, none of the data points will change their position. Hence, we can say that this is our final. So we divide our unlabeled observations into 2 clusters now. Thank you for listening my first lesson, and after this lesson I will upload another clustering algorithm called hierarchical clustering. If you have any doubts, any comments, you can put all those things in comment section, and I will answer those questions as soon as possible. Okay, goodbye.